embedded video on the Maine Foundation webpage. If you click through to the actual YouTube stream, there's a chat feature there. And if you have questions that come up throughout the lecture or during the Q&A, if you have a question you'd like Dr. Kling to answer, we can include that in the Q&A, in addition to those questions from the room, of course. So I'm so excited today to introduce Dr. Kathy Kling from Cornell University. Dr. Kling is a Tisch University professor in the Dyson School of Applied Economics and Management and faculty director at the Atkinson Center for a Sustainable Future. She's past director of the Center for Agricultural and Rural Development at Iowa State University, where she also held the president's chair in environmental economics. In addition, she served for 10 years on the EPA's Science Advisory Board. She was elected to the National Academy of Sciences in 2015, where she chairs their Water Science and Technology Board. Dr. Kling has published nearly 100 refereed journal articles and book chapters, which have received over 8,000 citations, and she serves as the editor of the Review of Environmental Economics and Policy, as well as the editor of the Proceedings of the National Academy of Sciences. She specializes in the economic valuation of ecosystem services and integrated assessment modeling for water quality modeling, and her research program has received over $7 million in funding from the National Science Foundation, the U.S. Department of Agriculture, the Iowa Department of Natural Resources, the EPA, and others. I could go on, but I won't. Dr. Kling clearly demonstrates the nexus between a robust academic research program and a commitment to public scholarship and policy impact that's at the heart of this lecture and much of the research done here at the University of Maine. So we're so excited to have her here today, Dr. Kathy Kling.
Okay, so 3 mics. Okay, how's that? Yes. This is good. We can do this. Okay. So, social costs of water quality, water pollution, or a name of that ilk is what the talk is going to be about today. I'm going to try to do 3 things, and I'm going to pay close attention to the clock because I was asked 40 minutes, and we're already a bit in, so I'll try to be sure to end within that. Number 1, I'm going to try to give you a broad overview of what we know about the state of the health of our waters across the country, water quality nationwide. Second, I'm going to try to give you an overview of how that water quality has changed over the past 50 years nationwide. Then I'm going to talk a little bit about environmental policy, and as much as time permits, I'm going to talk about some work we're doing to monetize, to think about how to quantify the trade-offs associated with pollution damages to our water bodies. So, step number 1. You would think in a country as large as ours, with the Environmental Protection Agency, Clean Water Act that was passed in 1972, that we would have a pretty good notion of the state of water quality in our local lakes, rivers, and streams. It turns out that is not so straightforward. In 1972, when the Clean Water Act was passed, it was very much passed with a lot of obligations and control by states. Much of the data collection was also given to states. As a consequence, there was not at that time or for many years a nationally consistent way to monitor and measure water quality. The EPA kind of finally realized this was a problem to really know what is the state of the health of our rivers, streams, and so on. So they started the National Aquatic Resource Surveys. And if you get on EPA's website, you can, they have some very, very nice information. You can get information about these resource surveys. And what they are is a snapshot taken at different points in time about the health of rivers and streams. That's 1 year. They do that across the country. Of lakes, they do those in different years. Wetlands and coastal estuaries. The goal, the idea here is every 5 or 6 years to redo on the same locations statistically based samples so that we know from one 5-year period to the next what is happening to the health of our coastal estuaries, for example. What you see here is a couple of snapshots of conditions. These happen to be the conditions in the Midwest. They're not that different from place to place. You only see a couple of, you see a 2008, 2012 lakes, 2011 wetlands, coastal estuaries 2010. I just said it was going to be every 5 years, right? Only when they provide money. Okay, so it's a wonderful thing. There are some seconds that have been done, but data hasn't been released. But at least now we have an accounting, a way to look at water quality over time. Short is that all of these forms of water bodies are not in great condition. They vary from poor to fair. Nitrogen and phosphorus, which I will refer to as nutrient pollution throughout this talk, are some of the dominant sources of pollution in these, all of these water bodies. One of the problems that comes from nutrients, eutrophication, and other issues is harmful algal blooms. How many folks know what a harmful algal bloom is? How many had heard of harmful algal blooms 15 years ago? Yeah, a bunch of weird nerds. Okay. Point being, of course, we are more aware in part because they are rapidly becoming worsening problems. The EPA now reports that all states are exposed and have these harmful algal blooms. These are naturally occurring algae that get fed nutrients, and nutrients do to them what they do to our agronomic crops. They make them grow like crazy, and they become seriously problematic in some cases. Now something that we're seeing broadly. This is some ugly pictures. This is a cyanobacteria bloom in a Midwestern lake. This is a picture from the National Geographic. No ducks were harmed in taking that picture. Don't worry. They're swimming through green, icky gunk, but they do okay, but it probably isn't their preferred habitat. So this is becoming increasingly a problem. What else do we know about current water quality? Well, I just told you about sort of these health indicators from EPA. I gave you a second piece of information about the prevalence now of harmful algal blooms. A third indication is the large dead zone, the hypoxic zone that occurs every year in the Gulf of Mexico. Show of hands again. How many people have heard of the dead zone or in the Gulf of Mexico? How many people would have heard of it 15 or 20 years ago? Again, a few nerds. Again, the point being, not only are we more aware, but much more we are learning about these issues. What I put up there is a map of the U.S. with the Mississippi Atchafalaya River Basin, which is that entire area and sub-river basins. All of that land area drains into the Gulf of Mexico. And in so doing, it collects nutrients, sediment, and channelizes it, drives it right down into the Gulf. As a consequence, the Gulf gets a large amount of nutrients, nitrogen and phosphorus, which are, of course, fertilizers, dumped into the Gulf each May, June. And if the weather conditions are right, it forms this hypoxic zone. The hypoxic zone is a zone where you literally, oxygen is too low for animals to live. This is, I love this picture. I can move now. I have this. I love this picture. This is not the hypoxic zone. This is the muddy Mississippi and all the sediment and nutrients it is bringing as it comes out of the channel and meets the beautiful blue ocean water. You get a real sense of how heavily laden that is with stuff. And one of the things it's heavily laden with is sediment that is carrying phosphorus as well as nitrogen. As a consequence, it feeds algae and phytoplankton. And if you look at this cartoon over here, that phytoplankton and algae grows with all that wonderful fertilizer. When it dies, it decomposes and goes through the water column. And in so doing, uses up oxygen. Every year, Dr. Nancy Rabelais from the University of Louisiana, Louisiana University Marine Consortium, I have it written there, goes out in what she refers to, they refer in oceanography, this is probably something all of you oceanographers do, as a cruise, which is quite hysterical. She had her arm broken once on this cruise as she got thrown from her bunk during a hurricane in the so it's not my notion of a cruise. That's not the cruise I want to go on. But what she does each year is she goes and measures the extent of this dead zone. And the dead zone means that there are, well, it's various levels of oxygen. 2 parts per million or below is considered completely hypoxic, which just means without oxygen, of course. And this is the 2021 cruise size. This is Louisiana, Texas, so it covers almost the entire southern part of Louisiana and on into Texas. An interesting side note, see how square the ends are? And see how it's still red at the end? Hypoxic zone is bigger than that. She just doesn't cruise it, because that's the coverage of her cruise. So we know that is a lower bound, an underestimate. These hypoxic zones are worldwide phenomenon. They have grown considerably in the last multiple decades. They are projected, as you can see in this map, to become much worse by the end of this century. This is a USGS NOAA climate prediction about the expanded size and magnitude conditional on different amounts of global warming. Because unfortunately, all of these algae and all of these problems, it's both nutrients and heat. And so we know that we are in a period where we will be seeing increased amounts of algae, phytoplankton growth, and these kinds of problems. She's been, just before we finish, she has been once a year doing measurements on the annual size of the hypoxic zone. Sometimes it's really big, sometimes it's really little. It turns out a really good hurricane, it's great for the hypoxic zone. Whips up all that water, reoxygenates it, so, but of course, hurricanes have their own problems, so we don't really want that to be used as the solution to these issues. So, so that's another kind of piece of information about the overall health nationwide of our waters. how do our waters compare now to 40 or 50 years ago? Well, I just made the point that it's not even that easy to know what they're doing now, never mind 50 years ago. But happily for us, a couple of all people economists, really wanted to be able to look at what's changed in water quality over time. And they did a lot of work to put together some very useful and extensive data sets that are out there, and combined them in order to make comparisons across the whole country. So I want to be very clear. Tons of people have been doing wonderful water quality work. They've been collecting data, and they've been storing it, many university folks. But what was not happening was making it in a way that is comparable across years and in the various storage places. So I don't want to make it sound like there wasn't an enormous amount of work. It just wasn't well organized. These guys did it. And what you see here is a map of the U.S., which shows where they got data from, about 50 million locations. Those red dots are them, at 170,000 pollution monitoring sites, so 50 million readings, from 1962 to 2001. So what they were really interested in was what's happened over time. And do we have data that allows us to answer those questions? So here's a very, very, very simple summary figure. What you see is 1962 to 2001, that 50-year period. And what you see plotted is the share of all of those 170,000, 50 million observations that are not fishable for each one of those years. Okay? Down is good. The share not fishable has declined. Okay, so there's an error bar around it. That tells you nothing about the distribution in different parts of the country. It tells you nothing about anything except that the long-term trend has, in fact, been down. It doesn't tell you if it's down enough. It doesn't tell you why it's down. It's just down. That's great. That's a really good thing to know. They were also able to find another similar metric, which is saturation deficit. This is the inverse of BOD, or something close to that. The ecologists can correct me. But again, down is good, the way they have measured this. Okay, so more oxygen in the water. It doesn't say it's enough. It doesn't say anything about causal, and it's just averages across the whole country. But at least this data is pretty compelling that we have made improvements, and that is great. Okay. Now, those are the only slides they'd actually made graphs of. They also have some summary tables. Here's one of them where they find other metrics that they were able to make comparable across all of these different points. And I want to point out two of them in particular. Negative is good, and statistically significant negative is what you're looking for, okay? Nitrates are, you have a positive number, but it is not statistically significant. So if you're a stats person, you know what that means. If you don't, it's fine. So basically what that means is it's zero. So 50 years, basically same nitrates we had as 50 years ago. Nitrite is positive. Okay, that's not good. And it has the little asterisks. So not only do we not, is it not zero, it's actually been going up. Okay? Does this make sense? Well, those of you who know about water quality and know about water quality policy are going, yeah, it does make sense. Why? Because we, and then the Clean Water Act, really ramped it up to reduce pollution from point sources of water, industrial, municipal. You had to have a permit and you had to cut back, but not agriculture. And agriculture is a large user of land and a large user of nutrients. And so the fact that that has not been something that's been regulated it's not terribly surprising to us economists, particularly, that this has not been a situation that's improved. Kind of to make this point, this is a map of agriculture in the United States. This shows you where agriculture is, and it gives you, I hope, a sense of the scale of agriculture in this country. We have, I learned today Maine has 5% agriculture. So you can see, most of it's forested, so you can see where Maine agriculture is. The dark green means that more than half of the land area in that pixel in that area is agriculture. So there is some, looks like some intensive, fairly intense agriculture up there. You see it spread all around. The Central Valley of California comes screaming out. Some pretty intense spots in Florida along the, and then Bahum, the Corn Belt. Dr. Libby's old stomping grounds, Ohio, my old stomping grounds, Iowa State. These are incredibly rich and productive farmlands. It's incredible what farmers and agriculturalists did to take that land and convert it into highly productive agriculture. A totally unintended but definite consequence, in economics we refer to them as externalities, is pollution runoff in the form of nitrogen and phosphorus. And I really think it's important, especially to an interdisciplinary crowd, to emphasize this is not intentional. And farmers now who continue to do things the way they do aren't intending to pollute. This is just the production process. Even those who adopt some practices to try to reduce, and can reduce some, to really reduce it to the amount needed is going to take some major change and cost some money. And they're private entrepreneurs, right? Most of us can't just afford to make changes when no one else is, to address a problem. So it needs to be thought about as an economics and social problem and a discussion, and we got to get away from too much finger pointing, which is something I think that is too problematic. That was my my map or my picture of the hypoxic zone. So if you want to know what has happened with the hypoxic zone over years, this is it. I should have had that earlier. Okay. I've given you what I hope is a snapshot of where we are. We do not have rivers and streams and lakes on fire like there was a time when we did, because point sources of pollution have really been well controlled. However, we do have nitrate and problems with phosphorus. So what I want to talk about now is some work that a group of us are working on. I've got a few tentative results to show you, more as an example of what it is that we're after, rather than any take-home, but what we're attempting to do here. This is a group of economists, and we also, not on here, but we're working with some hydrologists and others, so it's a pretty broad interdisciplinary team. What we want to do is build a model, a large, we're going to refer to it as an integrated assessment model of nutrient pollution across the United States, so that we can have a better understanding of where the sources of these nutrients are, how they move through our landscape, and ultimately what kinds of impact they have on ecosystem services and on people. Okay, social sorts of damages. The idea of what we're trying to build here, an integrated assessment model, is depicted in a kind of cartoon-like fashion here. We have emissions that come from somewhere. Okay, maybe if it's air pollution, it's a factory, but I'm going to be thinking about water pollution. So it's going to be from something that flows ultimately into water. Agricultural lands are a heavy contributor, but so are there's cities. There's lots of hardscape that also contributes this kind of pollution. There are some point sources of this pollution. Somewhere in the United States, these things get emitted, and then they flow across land into waters, where they then move from small streams up through bigger streams to large streams, and eventually they start to have impact on ecosystems and ecosystem services, creating some type of costs, damages to people. Again, it's an externality, it's not intended, but it nonetheless is a problem. It is imposing cost. What we want to do is build a model that incorporates all of these pieces, starting from the physical side, connecting through freight and transport, that is the movement of this stuff through the system, to where it ends up, and then as a consequence, to figure out what all these costs, these damages are. Many of you have heard of the social costs of carbon. We want to build an analog to that. In many ways, water can be argued to be more complicated because it is extremely place-based. Carbon emissions in one location do the same to global warming everywhere. So in a sense, it's a little easier, but even that, frankly, is not, because the damages from global warming are very place-based too. So sometimes people say, oh, it's really harder, and other times I'm like, well, we're just not doing a good enough job with place-based carbon damages either. But that's a separate story. Okay, what am I talking about when I talk about damages? I've talked about water quality, sort of physical, biophysical measures. Now I want to get into the more human domain and ecosystem services uses domain. Like, why do we care? Okay, well, we have in mind to start with 5 or 6 reasons that we care that have very relevant economic ecosystem service values. Okay, number 1 is drinking water. Okay, we all drink water. What you see a map of here, obviously United States, about 14% of people in the United States get their drinking water from private wells. I have no idea. Are you folks on private wells here? Lots of private wells? The 86% of us, like me in Ithaca, we get our drinking water through public drinking water systems. Public drinking water systems have to meet, they have to regularly test their water, and they have to regularly treat water if they don't meet standards. It's the law. If they don't, there'll be violations, big penalties, and so on. What happens if your private well doesn't meet the 10 parts per million nitrate standard? Many people don't even know. So the issue here is that people, and you can see this map shows where most of those people live. And it has to do with whether water is coming from the surface or whether it has to do with the geology of areas, whether you can pull well water out of it. And people in this room would know more than I do about how this all works. But there's heavy hotspots, as you can see in the east. There are in Iowa, where I was, there was a lot of, the green is also private wells. Places where you have private wells on top of agriculturally intensive landscapes are the most concern. So if you're on private wells here, I don't know what the ag influence is here, but the main point is you should just get your well tested. It's cheap. It's really not, and you just want to know. So but a lot of people don't test. Okay, so a really famous case happened when they had to shut down Toledo, Ohio, the drinking water. But of course, that was a public system, and they knew. Okay, they did not serve people toxic water, and that was harmful algal blooms as opposed to nitrates. But the idea is, if you're in an area where there's a lot of nitrates in water, you might not know. There's other bacteria and stuff you should be testing for anyway. So, but the point is, there's a lot of people that have it. Cooperative Extension and other sorts of NGOs have started to look at this more seriously, and not surprisingly, low-income, minority communities are the ones that are least likely to test, least likely to do things to address the problem. So there's some very interesting and important environmental justice issues here as well. Safe Drinking Water Act does not apply to those 14%. The Safe Drinking Water Act, with the rules and requirements, is only for public public systems. So that's number one. We want to monetize and measure those costs. Number two, recreational fishing, boating, wildlife viewing, etc., is one of the most common sources of enjoyment, recreation, of activity, leisure activity of Americans. Okay, people use the out of doors. They use it a lot, and there's really fascinating, interesting information. Clearly, under COVID, people used it a lot more. Okay, this was like having all this outdoor space, places that had outdoor space, had many more options about things to do than highly dense cities where you couldn't be outside. Anywhere from 140 to 150 million people report regularly using some sort of outdoor recreation, hiking, fishing, and so on. As you can see, about 13% as of 2019 participate just in freshwater fishing activities alone. It's a lot of people. Eutrophication, harmful algal blooms are icky. That's a scientific term, icky. You don't enjoy your experience. There are health effects associated with contact. There's also some concerns about eating fish and so on, but mostly the direct impacts that I'm talking about on this slide are things like altering ecosystems. Different fish and species can live in different areas depending on the amount of pollution. But it also can create problems, rashes, skin conditions. Dogs have eaten harmful algal blooms and died. There's some evidence that some cattle drinking out of farm ponds can succumb to these kinds of problems. There's your list, I won't read it for you, of what the CDC reports are all the kinds of things that can happen. And so contact recreation is particularly problematic. And so we are thinking about monetizing the health damages and so on associated with that is a third type of damage. Anybody got a house next to a lake or a river or a stream, maybe an ocean? Turns out people really like to live next to water. They really like to live next to clean water better than they do dirty water. We have some very clear, compelling studies that demonstrate that the property values of homes near a clean lake with exactly the same kind of house in the same type of location, but a dirtier lake, are different. Okay, people are willing to pay. They're willing to trade off other things in exchange to have improved water quality. That's the definition of economic value. Okay, people are willing to make trade-offs. They care about it. They're willing to forego a new pair of tennis shoes or a fancy vacation so that they can live in a house that is closer to clean water than dirty water. Those are called hedonic studies. It doesn't matter, but there's 135 million housing units in the United States that are within 500 meters of a lake alone, never mind rivers and streams. Those are almost all going to be impacted if the lake becomes eutrophied, harmful algal blooms, and so on. We are not early in our work, going to try to monetize anything with what a bundle of things I'm just going to call ecological disturbance. We hope to be able to do that later on, but we're going to go sort of for the easier hanging fruit of those other topics. We're also going to, it turns out this is pretty new science, that lakes that are healthy and natural store carbon. At least it's new evidence to me. Ecologists and others, limnologists, whatnot here might already know this, but there's now evidence that when these lakes become eutrophied, they stop being a sink and they become a source. And so we have greenhouse gases coming from these places as well, another source of damages. Okay, I'm getting close to the end, so what I'm going to do is I'm not going to talk you through this. I'm going to jump. I started late. I'm going to take 3 or 4 more minutes. Is that okay? All right. This is like I'm trying to sell you on our grand scheme, okay? All right. Here's our grand scheme that we're started and we got progress on. That's, of course, mapped the United States. Those are census tracts. We're going to use census tracts across the United States as basically our unit of analysis, our unit of observation, because we know how many people live in each one of those census tracts. We know something about the people, the average income, the average age, the average family size, and so on. So we can use that as a data layer on which to build this integrated assessment model. So that is a critically important piece of what we're doing. We're going to start with just lakes. Okay, so on top of that, we've got a lakes data layer. There's about 17,000 lakes in this country that are in the continental U.S. that are over a square kilometer. I don't even know what that means. I'm born and raised in Iowa. We don't, but you scientists use kilometer speak. So whatever that size that is, no, it's we don't have really dinky stuff here. So about 17,000 of these, and that's where they're located. That's another data layer that's essential for us. We need to know where the public drinking water outlets are. So we're not going to be looking initially at those wells that I talked about, but we are going to be looking at where the 86% of us get our drinking water, because there's cost to clean it in order to get it to meet standards. Okay, so that's a real easy computational cost. It doesn't capture all the costs, because there still could be health damages even below, and that conceptually belongs in econ models too. But you know, we're starting with just the highest level, easy stuff we can get. Okay, good. I just basically cut to the chase. There's a couple other data layers I have. But we've built a big model with a bunch of data that I'm not going to bore you with. I'm not telling you anything about. And as an example of what we're after, this is a map which takes a counterfactual, just a scenario, and says, suppose that we could, with a crystal, with a snap of the fingers, clean up all of those lakes, make a 10% improvement in the amount of phosphorus and nitrogen in those lakes. And through this tons of models, stuff that we've linked all together, we estimate that that would generate for recreational benefits, hunting, fishing, swimming, and so on, a total of about almost $15 billion value to recreational users of just those lakes. We've done the same thing, let me jump through here, for housing benefits. Okay, and this shows you where they are. That's about $21 billion. We are working to make this so it will be additive without double counting. So these are all results are all going to change, so don't take too much away from them, but this would then mean $35 billion value to people just from those two sources to improve the water quality by 10%. Final thing I want to show you that we're doing with this kind of analysis and data is, and the econ nerds here will totally get this. The rest of you, I'll I'll try to excite you as much as the econ nerds. This is what we call a Lorenz curve. And the whole point of this thing is to get at environmental justice issues. It's not just about what the total benefits are, it's about who gets them. Okay? And so what this thing does is says, of all those benefits I just showed you, what share of them go to low income, middle income, high income? If you had a perfectly even share, so the 10% poorest people got 10% of the benefits, the poorest 50%, the bottom 50% got 50%, then you would plot a line that's a straight line across that green thing. Okay? But that's not what happens. What we find here is, and this is for housing, this is the housing data, that in fact, if you look at the lowest 20% of income, they receive far less than 20% of the benefits. The fact that the line is below, the green and red lines, it doesn't matter which one you use, are far below, is an indication that those low-income households would actually only receive a relatively small amount. When you get the curved, more curved something it is, the more inequality there is. Why do we want to do that? Well, it demonstrates who gets these benefits, so that decision makers can think about, well, if we are going to improve these water and we're thinking about housing values, most of that is going to wealthy people. If I had shown you the picture for recreation, it's much flatter. Why? Because low and medium income folks use rivers, streams, and lakes for recreation as much or more than high-income people. Finally, I promise this is the last one, we've done the same thing and hope to do a lot more work on this along this area, not by income, but instead by percent white in a census tract. Okay, so rank order census tracts by the lowest percent white up to the highest percent, and you can also plot these out to see who, in terms of racial characterizations, are these benefits going to. Again, to provide information about fairness and justice for people in thinking about these. So I will stop there. I do think I took less than 40 minutes, but I didn't start till 10 after. So thank you very much. I'm delighted to hear comments, suggestions, and questions. Is it okay if I just? Yeah, please. So the question, I'm going to repeat just to be for clarity, is that what is this water quality that you're measuring, and is it the thing that is the most relevant to lots of different areas? So what I didn't tell you is we take all that nutrient data and various things, and we convert it into Secchi depth, which is a measure of visual, how far down you can see. And it is correlated strongly with nutrients as well as other things. So that's the metric that's behind all of this stuff. It does not capture the kinds of legacy pollution issues in the Great Lakes, New York Harbor. It does not, PFAS. We need some of you to start working on PFAS, please, really quickly. We got some problems there. If you don't know what that is, perfluorochloral, something and they're bad and they're in our water. It does not capture microplastics. So there are many other things that this does not incorporate that may be more important for environmental justice than these nutrients, which is a real fair point. Yeah, the question is, do people, when you look at the data and the literature, do people at different levels of income have different values, different willingness to pay is the economic term? The answer is absolutely yes. All else equal, if you have more money, you can, in fact, pay more. But there's also differences, not only, there are preferences that matter too. So as I mentioned, recreation turns out to be something that in these kinds of picnicking and boating and so on, there's actually even more use by low-income people than or middle income. And if you're a user of that stuff, no matter, you tend to do it throughout your whole life. And so we don't see those kinds of income things in recreation. We totally see it in housing values. So it depends, but it's very much part of all of this. We also see differences in household size, right? People that have a bunch of kids, they want to throw them in the car, let them go swim around, harmful algal blooms or whatever, just get out of my hair, and versus those who, don't have kids. So yes, that's all very much part of these kinds of models. Yeah.
Thank you. This is fantastic. I was wondering, there's been a lot of trends lately with dam removals, and that has some issues with sediment releases and water quality. How do you handle that with your model?
At the moment, we do not incorporate that at all. At the moment, the only way it enters any of our modeling is that we have behind a lot of this the sort of how water moves. Dams change how water moves. So in theory, once we get this really fully built, we could potentially say, okay, our current scenario has the dam. Next scenario is remove the dam and then predict where all the nutrients and sediments going to go and look at how that changes downstream. But we have absolutely none of that now. But it's a great point.
Is there any consideration made for legacy impacts that affect water quality over the long term? For instance, groundwater pathways that have high nutrient concentrations will persist for decades after the applications stop.
Absolutely. One of the important pieces that I didn't talk about at all is we have baseline water quality conditions. And so places that have a heavy level of phosphorus already, if we reduce upstream 10%, that will have less effect than places that don't have. I'm not, that's outside my area of expertise. I'm the economist working with, I think a lot of those numbers and estimates are still pretty rough, just like, there's debates about how much legacy effects there are, is my understanding. Nitrogen, maybe not so much. It moves pretty quickly. Phosphorus, they used to think it was only slow. Now there's some evidence, especially in tile drain systems, it goes pretty fast. So I think others could correct me, but I think there's still emergent science on all that. But I'd love to hear more from you if I have that wrong. Here and then here.
Thank you for the talk. As somebody who just recently moved from Iowa, it was very interesting to revisit the issues that were in the news there.
Yeah.
So the question I have is, I remember from following the debate about water quality in Iowa that there was some uncertainty about the health impacts of nitrate pollution, the acute health impacts,
yes,
but also the long-term chronic health impacts. So I was wondering how you're choosing to estimate those health impacts in your model.
Great question. The question is, well, what do we actually know about the long-run health impacts from nitrates? And it's an excellent question. It used to be the view that, well, if you're at 10 parts per million or below, no problem. That the only problem is if you're above that, and then you can have problems and really high above, blue baby syndrome and so on. But that's not a very common thing to happen anymore. Well, it turns out there is now an evolving science coming out of the University of Iowa, the lab there. They've done a bunch of work. There's starting to be stronger evidence that there are, even at low levels, connections to birth defects, and there's one form of cancer that I cannot recall offhand. It is also an emerging area of science with discussion and debate, but there was a National Academies thing I listened to where they're becoming more convinced that exposure over a long period of time at low levels, they're now seeing a clear footprint. They think, again, this is not my area, so at the moment, we have not attempted to monetize that. We plan to. And in order to do that, we need to know those epidemiology studies, like what is the risk, how many people are impacted, and then we can apply values to that. So again, great question, really important, and yeah, I don't know. I have a lot of I don't know answers. Yes.
That's really cool. It makes me wonder how because PFAS and other types of pesticides are so difficult to test, if nutrients might be correlated to something like that. Anyway, that was an aside thought. I was hoping that maybe there'd be some plans to create a tool to take this assessment model so that small towns and municipalities can pinpoint what's going on in their area and how they can make decisions to help make improvements.
That's a great question, and I would love to see that as something that evolves out of this. I think that's a long ways away, at least at the scale we're looking. What we do want to do, when we feel like we have some numbers that we really feel pretty comfortable with, which these are not them, I want to make a really nice big web interactive thing so that you can look at a map of the United States, go to your location, and see some of our estimates, and with explanation about the scale at which you should interpret them, blah, 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 all the stuff we always insist on. So at a large scale, a tool like that is very much on our planning. But at smaller scale, you need more refined data and so on. But great question, and could be really helpful. Todd.
So I think it was a previous slide where you showed the distribution across different income categories. Do you know if that's even sort of understating the disparity? Because you might think that higher income people would live closer to cleaner water to begin with. So the 10% scenario would not be as large of a cleaning the water as opposed to somebody that's living near a dirtier water source.
I like your intuition, and I'm inclined to agree with it. Yes, there may be other things going on, but I think you're right. That makes a lot of sense to me.
Yeah, I'm just
Yep. So in that sense, it would be an underestimate. I'm sorry, I'm not keeping track of who's in the order.
How effective a policy tool do you think valuation studies and cost-benefit analysis is in the federal government of 2021?
Okay, there's a couple questions I would say embedded a little bit there. Benefit cost analysis, these kinds of cost numbers are required by the federal government in order to do, for every regulation they do. And lots of people said, oh, well, they don't really matter. Turns out Al McGartland is he's basically the EPA's economist. He's been in that position, also University of Maryland graduate, Kathleen, Mario. And I shared an office with him once. I have his autograph. Al will say that has been hugely important, but lots of times it's kind of behind the scenes. That in his office, for example, the lead rules about lead standards for kids and dust outside of water, he says that those rules under Cass Sunstein and back in the day, that they implemented them faster and more stringently than they otherwise would have without the cost-benefit numbers. And that's not like in the public purview, but that they were able, because the damages to kids was so bad, and they had the documentation, and they were able to show it, people said, yeah, we got to do this. So I think there's an answer that is that kind of story answer. On the bigger picture, how much is it going to, like, oh, we're going to suddenly make a whole new set of regulations, or we're going to revise the Clean Water Act? No. But according to Al and others, that it really does make a difference. It's like the social cost of carbon. I look at that and I say, that has focused the conversation. Every social cost of carbon number you've ever seen is ridiculously wrong. Okay, it's not the correct number, but it's like it gets us talking and thinking about there are costs here. What are they? How close is there? They're going to come out with a new number. It's going to be way bigger finally, because it's really been clearly an underestimate for a long time. But so that's my long-winded answer, is I don't know. But I do think it matters. I hope it matters. Yes.
Yep. Glad that you brought up Al, my old boss. So that's
Yeah.
good. I can attest that EPA does take cost-benefit analysis.
There you go. There's the man right there. Said it.
So this is from the chat, from people watching online. Can you ask Kathy how high she expects the social cost of water pollution to be per unit X? And how, if that comes out, similar to social cost of carbon, how EPA might best use that number for policy making.
Well, the number's going to be 40. I'm not going to tell you dollars per what unit. Yeah. I don't know. What I do know is it's going to be place specific, and you know what? Just common sense is the highest locations for the most damages is where people live. Okay, and where people are swimming and engaging and drinking the water, and we know that just simple math will do that. So I don't know. How EPA will use it is a fabulous question. So how will EPA use it?
In a way, I mean, I think what you do is you're combining a lot of information that EPA has used in the past, right? And so
Yes.
maybe this will help bring it together.
Yes.
To make it, in a way, more digestible by the public to understand, here's what we're taking across a whole suite of things.
Yes, and to whomever asked that question, thanks. I don't mean to be flip about it. I know that EPA is very interested. EPA has supported some of our work, and it's part of their communications, of how they think. And these sorts of numbers can be used, in some cases, in their benefit cost analysis regulations. And so EPA is very interested, and I hope that it will be very directly used to improve decision-making in regulations. Everybody's looking outside. Oh, Kathleen stopped everybody, and then I'll come to you too.
Kathy, this is really exciting work. I was wondering if you've inspired folks perhaps in other countries to be doing similar kind of work so that we can see a network of groups kind of moving towards this shared goal.
You know, Steve Pulaski and Gretchen Daly, they have this thing called the Natural Capital Project. They have the INVEST model, which is doing analogous kinds of things. It's not this sort of spatial linking like we do. Steve is an avid supporter of how we need to do this around the world. In particular, things like green GDP, right, where we can really begin to monetize and measure the impacts on people around the world. So I don't think I'll live long enough to do that, but I think that should be done. What I will do is give some free publicity to the World Bank. This last summer, they came out with a report called The Economic Value of Nature, where for the first time I've seen, they actually valued around the world pollinators, which is really valuable, services, the value of commercial fisheries that are, go out and fish in the ocean, and some forestry, and added it to GDP figures. So if you're interested in that kind of work, if you can Google it, really nicely done, where they're really beginning to do this finally, and I think that's really exciting stuff.
So in your preliminary numbers, you've shown that there is essentially $35 billion back to people through clean water. If you could direct policy, what would you prioritize that they focus on first? What sort of costs do you think would go into cleaning up one thing of your choice?
Well, I was in Iowa for 25 years and observed water quality is not improved. The programs, the policy is voluntary. The Chesapeake Bay has had some areas where there's been improvement, where it has not been voluntary. There are a lot of programs where it's voluntary if taxpayers pay, which isn't that a weird use of the term voluntary? Does anybody else find that weird to me? Like, when you'll hear like, oh yeah, they'll do it voluntarily, but cost is a barrier. It's like, yeah. So we got to pay them. That's a fee for service. Anyway, so I would say we got to either decide we want to address these problems and then do policy that requires change, or stand down and say we're never going to get that hypoxic zone to a size that it was. I get frustrated with we're making progress, we're this, that, when there's not much evidence that we are. But that's why I'll never be in political office, because that isn't going to happen anytime soon. You never know. Yes?
Yeah, I just wanted to comment on your point about the green GDP and how there's now an act, the GPI Act, which is the Genuine Progress Indicator.
Okay.
Which Ilhan Omar introduced to Congress over the summer, but it's an alternative.
Cool.
That can be used alongside
Yep.
GDP.
Nice.
But I had a question, which was, I noticed that the phosphorus didn't actually decrease.
Yes.
I was wondering why that was.
Yes, a great question. And that's because phosphorus has had some actual controls. A huge thing is requirements on laundry, like we're phosphorus-free laundry. Phosphorus comes from agriculture, but it also comes from a number of power plant, industrial plants. And that's been cut back significantly. And so we've definitely made progress on phosphorus. Whether when you look at the health of our rivers, streams, and lakes, they are still too phosphorus laden to get us to those higher quality levels, but we have absolutely made progress. And so, yeah, it's really important to remember we've made some great progress in lots of areas, and that's one for sure. Yeah.
I think this might have to be the last question.
You get the last question.
You get the last word.
Related to that, do we actually have good data on trends in agricultural non-point source pollution, like progress or lack of progress on that, and/or models of how that may change in the future with like increased rainfall events?
So I'll try to make a really quick answer. I showed you the hypoxic zone. There is something called the Hypoxia Task Force, which is a federal task force. All states have members of that. All states are supposed to document their progress. Most of that documentation is pretty non-existent, or it's plans for what they might do, or it's simply reporting of how many acres they have in a cover crop this year. So my shortest answer is no, we really don't. Others would disagree because they point to those reports. We know with climate change this is all going to get worse. Bad rainstorms, big, very bad for washing nutrients out. Okay, I'll stop. It was them, not me.
Well, I invite everyone to continue the conversation at the reception, which is set up outside. And the committee did want to present Dr. Kling with an original piece of art from
Oh my gosh.
a print from Maine artist Mark McCullough,
Oh my gosh.
which has actually had 3 different years on it. So it is in fact 2021.
I love birds. It's a bird. It's gulls. You'll have to tell me what kind of gull this is.
We'll use the Merlin app.
Oh yes, that's right. I'll type it into my Merlin app. And cool. Oh, thank you so much.
Thank you so much, Dr. Kling.